Okay, so let's start off by making a turret. Let's drag this over here and scale it. Won't work in that size. Make something simple, and we want another part. This will be the gun, let's say. Okay, and both of these, let's call this the base, and we'll call this part the gun. That'll do. Maybe whatever you like, as long as you marry everything up. And make that into a group, which we'll call turrets. And then these parts need attachments in them, so that we can put the hinge constraint to make it into a servo. Attachment. Brilliant. Let's move this one up a bit. I'm not going to worry about this looking good, but you can make yours look good. Okay, right, now we've got those. Let's face them in the correct direction. So it looks like they're on their side. Yeah, orange is forward, yellow is up. Or I could be wrong about that. We'll find out any second now. Let's put the hinge on there. So let's put the hinge into the base, like so, and give it its attachments, like so. Okay, so I think that's facing forward. We shall put actuate the actuator type to servo, which is going to point it where we want it to point. And we need to give it some torque. So I'm just going to stick a bunch of 9s in the torque and the angular speed. Let's just give it a bit of speed. You can increase that if you want. You know, that's all down to how you want your turret to behave. Okay, so now that we've got that, let's just press play and see if that floats as it should do. Oh, got to anchor the part there, of course. Newbie mistake. Anchor. Okay, doesn't look like it's quite floating. Ah, because that one shouldn't be. Move that down a bit. Now it should float a little bit. There we go. Obviously, you can adjust yours to be better looking than having a big gap like that, but we don't need to worry about that. We're just trying to make it point in the direction around that hinge where the mouse is pointing to. So, first of all, we want to get that world position where the mouse is. So let's do that with a local script inside starter players, starter characters, scripts. Yeah, let's just do that. And there'll be one every time. This will be running every time. So we're going to want quite a few services, I think, for this actually. Obviously, we want to get the local player, so let's get the player service. Get service players. And we're going to want the user input service in order to get the mouse's location on the screen. So let's call it UIS equals game get service user input service. And we'll want replicated storage in order to fire a remote event. So let's just be lazy and call that rep again. So local rep equals game get service replicated storage. And we'll also want the run service because we want this to run every single frame. So local run service equals game get service run service. There we go, just like that. Okay, so like I said, we need to get the player. We would later call it PLR equals players dot local player because it's a local script, so we can get the player from that. And we're going to want to get the camera. Camera equals yeah. So we're going to get the camera is the game.workspace.current camera, like that. And we want to make an event in replicated storage. We'll call that, well, we'll just leave it as remote event. You'll sort out yours however you want them. So let's call this, call event equals rep wait for child remote event. Brilliant. Now that we've got those, we want a function to, actually let's just connect to the run service. So run service dot heartbeat. Yeah, heartbeat should be fine for this. Connect function. And then in here, we want to get the mouse's screen position. So let's call that local, let's call it cursor. Cursor position. There we go. Cursor position will do fine. Equals user input service. Gets mouse location. Get mouse location just like that. That returns us a vector2 that includes the where the X and the Y on the screen. So yep, we can then, yeah, then we need to make a function to turn that into its world position. So let's make a function here called local function. Let's call it world mouse or world cursor, whatever we call it, whatever you like. We're going to put an X and a Y in here, and we're going to do that from this bit here. So let's turn that into a full function. We're going to call that with this way here, world mouse, and we're going to pass it the cursor position dot X and the cursor position dot Y. So an X and a Y because this is going to be a vector 2. Okay, now that we've got that, that's essentially what we're going to be passing. So we might as well just put that in now. We're going to be doing the event dot fire, sorry, colon fire server, and that's what we'll be passing to it. Yeah, that'll be passed because what we're going to do here is we'll be returning the position. Actually, let's not even write that in yet because we've got to raycast first. So first of all, from here we need to do the camera screen point to ray. So that's how we get a vector from the camera to the direction it's looking. We're using where the mouse is and where the camera is to give us a vector that we're pointing in. We're going to cast a ray on that vector. So give a screen ray, quite a common name for this one, I think. Equals camera screen point to ray, just like that. And then we're going to put that X and that Y into this, like that. And then let's do a ray. So the new system workspace, and then we raycast like this. We don't make a ray in the same way anymore. Screen ray. We want the origin of it, which is where the camera is, and we want the direction of that ray is going to be the screen ray direction. So dot direction, just like that. Now the thing is the direction is just a vector, so it adds up to 1. So we don't want to just raycast 1. We want to times it by something. So times by, let's just go with 1,000. That's going to be basically the range from the camera that this works. So you can go larger or you can shorten it. But if you don't use this as like the range of the turret, because that won't really work because it's the camera, not the player itself. So next, we then want to check if there is a ray. So we only want to return it if there is a ray. So if there is if ray, then return ray. Otherwise, we don't want to. Oh, we've got an equals here. There we go. Okay, so now that returns the. Oh, that we want to return the position of the ray. So ray dot position. There we go. That's it. So if there's a ray, then we'll return its position, and that should send us what we want. Let's just have a print in here to check that ray position. Press play to check that we're actually getting that. Yep, looks like, yeah, that looks like we're getting the world space. Obviously, it's, oh, remote venting. Oh, we're just sending too many. Okay, that's fair enough. Oh, that is what it is. Lesson for another day, how to limit that kind of thing. Okay, we want to, now we need to do something with the server side of things. Okay, so I'm just going to stick a script straight into the turret, like a noob. And what next? Okay, well, we need replicated storage again, because we want to get that event. Who's game dot get service, sorry. Not get attribute, what's going on here? Service. And we want replicated storage. Perfect. Local event equals rep wait for child remote event. Now let's also, I think the base would be the easiest one here. So local base equals script parent base. Yeah, that should be good. And because the script is inside it, everything should be loaded before the script executes. So you shouldn't need a wait for child on that one. Okay, now then, off of the event, we want to go off of the on server event of that one. So whenever this event is fired, connect to that. I want to put the function in anonymously here. It will pass the player first, although we're not using it. So you could just use an underscore like that. But for the sake of this, we'll show what it is. And then the mouse position, let's call it. There we go, mouse position. And that's going to be, like we see, that's going to be the same as these numbers here. It's going to be a vector 3. Okay, so now if it actually passes in mouse position, let's just double check it is. I'm not sure if I need to double check this here, but I'm going to because I've had enough time with this now. Okay, we want to get an X and a Y. Let's call it my X, just to distinguish it from normal X. And in here, so we want to get that mouse position, X, and from that we need to take away the position that the gun's shooting from. So that's the base, but not just the base's position, we need the attachment inside the base. And then not the attachment's position, because that will be just an offset of the thing. So then we use the world position, and that's it. That's the attachment's position in the world. And then we want that thing's .x. Okay, I hope you followed that right. So this is basically the x coordinate of where the attachment is in the world. And we're going to do the same thing for the y. So basically just copy this line and we'll make it y like so. Oh, in fact, all of these x's turns to y. No, z's. That's where I went wrong before. Okay, so my y is going to be the z position. Sorry, I've been working in Blender, and Z is the up axis, so it's been a rather confusing one for me. Right, so Z, we want the Z, and that's going to actually be our Y, if that makes any sense. And what we're going to do is we're going to get the theta, and that's going to be relatively straightforward. We've got the math dot inverse tan, so that's the 8 tan 2 of my X and my Y. That should give us the theta of the thing, and then we just, from that we can just use math.degree to get the actual degree. So let's go with the base dot hinge constraint. Yeah, hinge constraint, and then the target angle of that hinge constraint. That's what we'll set it. So target angle, and then that's going to equal math dot degree. Oh, sorry, yeah, we have to change it to degrees because this theta is going to be as a radian, and this accepts degrees. So I'm not going to bother with any of my own maths there. It's all built into Roblox. Let's just use math.degree, and then we're going to chuck our theta into there. That should do it. Let's just double check that. Yep. Okay. And I hope it should find the shortest route, whatever we do, because hinges are nuts like that. And obviously we can change the speed that this behaves by just changing this angular speed up. Let's put that up to 10. That should, there we go. You see that makes it much more responsive. Great, I hope that helped. If it did, make sure to like and comment and subscribe and all of that good stuff. And yeah, obviously, if this doesn't help you out, let me know as well. I'll try and clarify anything that doesn't make sense. Best of luck.